Okay, welcome to Chapter 16's video lecture on water. So we're going to get started. You should probably already know most of this stuff, but I'd like to review the unique properties of water. First of all, hydrogen bonds hold water molecules to each other, and then we get effects like cohesion and adhesion because of that. In addition, the temperature of water changes really slowly. Water has a really high specific heat, so that's the amount of heat required to change 1 degree Celsius, and it's really, really high, so it takes a lot of energy to change the water. Water is called the universal solvent. It dissolves many compounds, and a lot of energy is needed to evaporate water. So industrial coolant modifies local climates, and then water expands when it freezes, which is unique. Also, you might remember from the first unit way back when that water is most dense at 4 degrees Celsius, and we'll come back to that here in a little bit. 70% of the Earth's surface is covered by water, but of that, only 2.5% is actually fresh water, and we saw that on our first day in class. Potable is the definition of unpolluted fresh water suitable for drinking. And so potable water is even less of that 2.5%. Shortages in water can be attributed to human-induced water pollution. The World Health Organization estimates that 1.4 billion people do not have access to safe drinking water. That's billion with a B. They categorize these numbers, and it looks like the contaminated water in China, that's 700 million people that don't have safe water. India, it's 300 million that don't have safe water. Russia, that's half of the tap of all the tap water is unfit to drink. And in Africa, 290 million people don't have safe water. So here we have our total world resources of water. And if we zoom in on the fresh water, which we do here, we have rivers and lakes and groundwater and ice and glaciers. So we talked about that only some of that water is actually accessible. So then we have groundwater that's accessible, and rivers and lakes, which is accessible, and then not really in the soil. So the amount of water that's accessible and then the amount of water that's accessible and potable, the number gets even smaller. In North America, each person uses approximately 100 gallons of water a day. 100 gallons. You go, Miss Dowd, I didn't even drink a full gallon of water. How am I using 100 gallons? That's not true. Well, sorry for the bell. For starters, you know that we did the water audit, so you saw how many gallons you used. But of that 100 gallons, 70% is used to carry away waste. So going to the bathroom, those sort of things. 30% are used for lawns and garden, and then a very small fraction is actually used for drinking. So we have this large amount of waste, and we have to deal with it, and currently natural processes cannot cope with this with the highly concentrated urban waste, so therefore we treat our urban waste at sewer treatment plants. So if we zoom in on urban domestic water uses, here we have bathing is 23%, toilets at 29%, dishes are 6%, drinking and cooking is only 2% of our normal water use. There are lawns, which are 29%, and laundry, which is 11%. Okay, this is a review from the first unit where we talked about cycling of nutrients and water cycling. So lakes have fall and spring turnover where temperature differences create mixing. This brings the bottom nutrients to the top. So remember that water is the most dense at 4 degrees. So no matter what, if it's summer or winter, the 4 degree temperature is going to be at the bottom. And in the fall and the spring, we get a changeover of the temperatures. We have changing of the water, and we actually get the mixing going on. In the fall and the winter, we have our 3 layers of the lake and the characteristics that are found there. This slide is also a review from the prior units, but it's good, we can go over it now. There are kinds and sources of water pollution. So dissolved organic matter is a significant water pollution problem. We have biogeochemical oxygen demand, or BOD. And this is the amount of oxygen required to decay a certain amount of organic matter. If too much organic matter is added, all the available oxygen will be used up by bacteria by doing cellular respiration, breaking down organic matter, and then because of that, we'll get hypoxic or eutrophic or dead zones. So there's an inverse relationship. An increase in biological oxygen demand decreases the dissolved oxygen. Another type of water pollution that we've spent a lot of time on is eutrophication. So eutrophication is the excessive growth of algae and aquatic plants due to added nutrients such as nitrates and phosphates. Eutrophication typically is caused by humans, as we discussed in our first unit. So here we have a picture of a lake or a river, and we have a source of pollution. And so we can look at the amount of oxygen demand or dissolved oxygen prior to the pollution and then after the pollution. And you can see that before the pollution, it's at 8 parts per million of dissolved oxygen. And then after the pollution, we have 0 parts per million dissolved oxygen. So a fish that's here cannot live, they would die. And then if we go a little bit further downstream, because of mixing, we would have 2 parts per million and eventually 3, 4, 5, 6. And at the end here, even though it's several kilometers past that one point of pollution, it's not equal to what the water was before. I know this picture isn't in your notes, but I would like you to add it to your notes. And I would like you to label what's happening in A, B, C, D, and E. So when talking about pollution, there are different kinds of pollution. A pollution that we know exactly where the source was is called a point source pollution. So this is like industrial waste discharge, just like in the image we saw below or before, with that one pipe coming out. That is a point source of water pollution. Non-point is pollution discharge not from just a single point. So an example of that is agricultural runoff, which is the largest source of water pollution. Currently, the EPA is doing a wonderful job regulating point source, but we need to increase our regulation of non-point source. To continue on the kinds and source of water pollution, the next type of area that I would like to address is the municipal water pollution, which is waste from homes that consists primarily of organic matter from garbage, food production, and human waste. One type of bacteria that is typically found in municipal water pollution is fecal coliform bacteria, which is the bacteria you are researching for your debate. Fecal coliform bacteria is a generic term for bacteria found in humans and other warm-blooded animals that live in the intestines. The numbers and types of bacteria present in the water are directly related to the amount of fecal matter entering the system. So you're going to see more bacteria if there's more fecal matter and less bacteria if there's less. Industrial water pollution. Factories and industrial complexes frequently dispose of waste in municipal sewage systems, so that's our sewage system. It may require special wastewater treatment. It is often point sources, and we then aren't able to clean them up appropriately. Another example of industrial water pollution is through mining, because we get chemical runoff and then we get acid mine drainage, which we talked about in our last unit. Another change to the water, which is a type of pollution, is thermal pollution. Thermal pollution occurs when water is withdrawn for cooling purposes and then that heat of water is returned to the original source. This is key in nuclear power. They use the water to cool the plant, and as a result they return the warm water to the river, and that changes the river. An increase in temperature, even a few degrees, may significantly alter the aquatic ecosystem. An increase in temperature decreases the amount of dissolved oxygen. A change in water temperature could cause species to not spawn. Even water treatment plants release water that's warmer than the creek it's entering. An example of who's not doing this is Roseville, because Roseville has built a cooling plant to cool all the water. So it pulls the water, and then when it puts it back, the water's the same temperature. In 1969, the Cuyahoga River, Caught on fire. Literally, there were so many pollutants in the water that it caught on fire. So this spawned the Clean Air Act and the Clean Water Act that followed shortly after this. Okay, because of such events that I just showed you, finally 2 acts were passed. The first act was the Clean Water Act in 1972. This act established the basic structure for regulating discharges for point source pollutants into the waters of the United States and to make them swimmable and fishable. It gave the EPA the power to implement pollution control programs such as setting wastewater standards for industry. The act made it unlawful for any person to discharge pollutant from a point source into navigable waters unless permit was obtained, which is still scary because they can still do that. It was also funded by the construction of sewer treatment plants under the Construction Grants Program and recognized the need of planning to address the critical problems posed by non-point solutions. So prior to 1972, these things that we take for granted didn't exist. In 1974, the Safe Drinking Water Act was established to protect the quality of drinking water in the United States. Under the authority of the Safe Water Drinking Act, the EPA set standards for approximately 90 contaminants in the drinking water. For each of these contaminants, the EPA sets a legal limit called the maximum contaminant level. Now, what's crazy though is that there are more things in our water than these 90 and they're not regulated. Hey, welcome to Chapter 16, Part 2 of this video lecture. We're looking at the largest freshwater lake on the planet here, and it happens to be found in Russia, and it also is 400 miles long. So what do we do with our water that goes out of our house out of our sewer into the sewer treatment plant? What happens? So wastewater treatment, there's a process that goes with it. The first step of that process is primary treatment. And here it's the physical stage. So all the large debris and particles are filtered out via screening and then pumps to retain to the remaining water. These particles are sent to a landfill. These are like diapers that get sent down the garbage disposal or down the toilet, or large debris. Sometimes chemically treated polymers may be added to help suspend particles and separate and settle out. After settling, water is drawn off the top, and although devoid of large particulate matter, it's still very heavy in organic matter, dissolved salts, bacteria, and microorganisms. At any point, this is totally not okay to put back in the lake yet. The second stage of the treatment plant is called the second treatment. This is also biological, so facilities designed to degrade organic matter by promoting bacteria and other microorganism growth. There's a couple different ways. One way is activated sludge. This is a wastewater mixture with large quantities of highly oxygenated water. The other thing is trickle filtrating system, which provides an anchor substrate for bacteria. The discharged water must be still disinfected, so it's usually done with UV or can be done with ozone. And it's usually accomplished via chlorine as well. So here's a few pictures of those two processes. So we have the activated sludge up here, and we have the trickle filter down below. The next stage is the tertiary treatment and runoff. Some plants now utilize an additional stage to remove even more dissolved pollutants, in particular phosphorus and nitrogen. This is extremely costly, so most municipalities using natural or constructed wetlands. Some areas use the effluent as fertilizer or to irrigate golf courses, roadside vegetation, or cropland, and this is recycled water. So another way we get our water, if we don't get it from a river, is we get it from underground mining. Underground mining is just groundwater being removed from the ground. So removing water from an aquifer faster than it can replenish. The extended periods of mining can lead to land subsidence. This is where we see an increase in the land height. Lowering of the water table, which we saw a video on that about a person in Central Valley having to drill deeper and deeper wells to reach the water table. This causes plants and trees to die if roots cannot reach the groundwater, and saltwater intrusion to wells near coastal areas also happens. An additional act that came forth in 1968 was the United States Federal Wild and Scenic Rivers Act. This was established system to protect wild and scenic rivers from development. All federal agencies must take these areas into consideration when planning and implementing procedures. The Yuba River is an example of a river protected under the Wild and Scenic Rivers Act. The Safe Drinking Water Act is dealing with groundwater, lakes, rivers used for consumption. It establishes primary drinking water standards and establishes groundwater protection program. So one additional source of pollution to groundwater is marine oil pollution. Tanker accidents are spectacular, but more oil is released as a result of a small regular release from other resources. So 2/3 of all human-caused marine oil are from street runoff, improper disposal of lubricating oil, that's why you must recycle your oil, intentional oil discharges during tanker loading and unloading. In 1992, new oil tankers must be double-hauled. Currently, 50% of all tankers are double-hauled, so that means that 85% aren't. Having a double hull ensures that if one part of the ship gets a puncture to it, that it actually can still hold the oil. Groundwater pollution, the major sources of groundwater pollution are agriculture products, underground storage tanks, landfills, septic tanks, and surface impoundments. So here's an image of all the potential groundwater contamination. So you can see on here all the different sources of that. So water use planning issues, metropolitan areas must deal with and provide 3 basic services: water supply for industrial needs, wastewater collection and treatment, and stormwater collection and management. They must also deal with the great volumes of excess water during the storm, so the stormwater runoff. Urban areas are paved unless little water can be absorbed into the ground. We need surfaces that aren't paved in order for water to get soaked into the ground. Salinization. As plants extract water from the ground, salt content is left, and over time it increases, unless there's some sort of flood that washes it away. Irrigation of arid farmland can make salinization increase due to increased evaporation rates. And then we've seen what has happened to our seeds as a result of salinization. Our last slide here is a review from Unit 1, so be sure that you know all of these layers.